See my screen. The UV task force also looked into another risk associated with 4 UVC lamps, which are krypton chloride lamps, and that is the generation of ozone by these lamps. The risk is different than normal GUV lamps, mercury-based lamps, because mercury-based lamps, you can make them basically ozone-free by choosing glass. With krypton chloride lamps, you don't have that option, so these lamps definitely do create ozone. What is ozone? It's basically an unstable gas, oxygen, and it has a third atom attached to it, so it's unstable and highly reactive, oxidizing, and it's very heavily regulated, but it's also widely used in water disinfection in the food industry. The good thing is normal people can smell ozone at very low concentrations of about 30 ppb. And the limits, the threshold limits that are being set, at least in the United States, are down to 50 ppb or 0.05 ppm, depending on exposure time and so on. They can be slightly higher. I assume that these values are not much different around the world. So we talk about 50 ppb as a maximum exposure. How is ozone generated in lamps, by lamps? There's essentially two ways, either by radiation, UV wavelengths, and electrical discharges. And I want to make it clear upfront, we are talking about the ozone generated by a lamp. We will get into that later, but this is not necessarily what is being emitted into a room. So, ozone generation by radiation. Since the ozone layer is a very, very important part of our atmosphere that has been researched and understood for a long, long time, it is very much related to the absorption of the oxygen to UV photons. And this graph here shows the absorption of oxygen. And you can see this is logarithmic absorption, and it drops off very steeply in the so-called vacuum UV range below 200 nanometer, but there is still some absorption at 222 nanometer left. But in practical terms, for the lamps, it is more important that krypton chloride lamps have a little bit of a peak below 200 nanometer. And since the absorption is basically exponentially dependent, this little peak has a much higher impact on ozone generation by radiation than the 222. More important in practical purposes seems to be the ozone generation by discharge. These lamps are excimer lamps. That means there's no electrodes inside, and the lamps are driven by very high voltages, typically somewhere between 2 kilovolt and 10 kilovolt, which are basically applied to the outside of a glass bulb. And then it depends how the lamp is built, how big is the voltage, what is the power. Little discharges can form on the outside of the lamp, so-called corona discharges. And these discharges create a lot of ozone in air. And that amount is usually much, much higher than whatever is being created by radiation. And since it is a discharge, it depends on the parameters, especially the driving voltage, and of course the lamp power. That being said, the ozone generation will depend on the lamp design and the lamp power. But there's ways to reduce the ozone. In applications, always remember the ozone generated by a lamp is not necessarily the ozone emitted into a room. You can block the ozone. You can modify fixture design. Just by enclosing the lamp, the ozone will be trapped, most of the ozone at least. If necessary, you can put ozone destruction filters into the fixture. In fixtures, you can also just add a quartz window that will block some of the ozone or most of the ozone from coming out. In practical applications, ozone naturally decays, but fairly slowly. But one thing to remember, ozone is very highly reactive. So many organic materials react very quickly with ozone, especially nylon and rubber materials. And of course, that will eat up ozone. Overall, the easiest way to lower ozone concentrations is, of course, ventilation, air exchange, and that is the most efficient and easiest way. Nonetheless, the goal should be to create the least amount of ozone in a room. The ozone concentration can be calculated. You can look into our paper for more details. An important measurement is the ozone generation rate of a lamp. Now, I want to say that this ozone generation rate, of course, only takes the generation into account. In practical environments, you will have ozone destruction and other effects. So when you calculate ozone concentrations with this formula, you can expect that in practical measurements, it will always be less. And of course, the formula assumes that the air is perfectly mixed, which may not be true. Nonetheless, it is a good way to at least make some estimates for the expected concentration in rooms. Now, how do you measure the ozone generation rate? For really strong ozone generating lamps like mercury lamps or xenon excimer lamps, they are typically put into a tube. You flush some air or oxygen over it and measure the ozone concentration at the output. Now, these lamps, these krypton chloride lamps, at least the modern ones, are not necessarily tubes, and they are also creating such a small amount of ozone that it becomes very challenging. So in the task force, we investigated different methods how the ozone can be measured. We came up with a relatively quick and simple way. If you enclose such a lamp into an enclosed volume, small one, like shown here, 35 liters about, made from a material that does not react with ozone. You turn on the lamp and you measure the ozone concentration over time. And the gradient of this ozone generation, basically ozone concentration, basically shows you, gives you the ozone generation rate. We compared a few data that we could get from various lamp manufacturers of various lamps. And as you can see, the values vary quite a bit. So one lamp created 85 micrograms per hour, which is a very small value. Another one, 12 micrograms. And then we get into different kind of lamps, what I mentioned before, the cylindrical lamps. So a 75 watt lamp creating 12 milligrams per hour. Another lamp which is much higher wattage, but is built differently than that 75 watt lamp, only gives 1.3 milligrams. So just to emphasize, the ozone generation will depend on the lamp design and the power. So in the United States, there is a UL 867 that is being applied for air cleaners and is measuring the ozone concentration. That is based on a sample room of 1,000 cubic feet, almost 30 cubic meter. And we can basically do some calculations for these lamps that I showed before and estimate how much concentration will this lamp create. Remember, in practical application, 0.05 ppm. This UL 867 standard basically sets the limit at 50 ppm. So if we take these two low power lamps, you see that the concentrations would be far below the limits of 50 ppb. But these higher power lamps can very much exceed these limits. But it has to be considered, so this assumes 24-hour on. In practical application, especially if you work with ACG/IH limits, the on time of these lamps will be much, much lower. Yeah, you see, it's basically with these low power lamps, 0. With the 300 watt lamp, you may get close to the limits. But I mentioned before, the data in real measurements will be much lower. For instance, with lamp B, there have been actual measurements under UL 867, and the measurement results were essentially 0 or at the measurement resolution and limit. And also we have one other data point. If you take lamp A and put just a quartz window in front of the lamp, the ozone generation drops by 2/3 very quick. So there is simple ways to lower the ozone emittance into a room, but these data also show you must do your homework. You must go at least to your lamp supplier and get the data so that you can do your estimates. And at the end, you will have to do ozone testing anyway, especially if you want to sell in the state of California, because there it has basically become mandatory for UVC fixtures are considered air cleaners and must be certified under UL 867 for ozone generation. And I am not familiar enough with international regulations, but I assume it is not much different. When you go into testing, always keep in mind you are not testing the lamp or not even the fixture in always on time. If you apply a fixture, you want to run it with the actual on time of the lamp. That is likely much, much shorter than 8 hours, and you will run it with ACG/IH limit, so it may only be on for half an hour in 8 hours or something like that. And the ozone generation will be even lower. At the moment, unfortunately, there's no way to get around it, even if every manufacturer tests the same exact lamp and the same design, you still have to get your own data. Yeah, I mentioned, yeah, you should, in your fixture designs, you should decrease the ozone emission to the minimum. Ozone is a dangerous gas. And we should limit the exposure to people to an absolute minimum. And that is it from my side. Thank you very much.